Hey guys, welcome to the 2019 MCAT exam paper. This is day one from last year. So how this whole video works out is that I go through each question, go through the answers, tell you what you guys need to do for achieve merit and excellence. Now, some questions, there are more than one way to do this particular answer. I try and show you guys the efficient way according to my perspective, and of course you might actually find some other way that's completely works for you as well. So yeah, so the other thing also I'd recommend is that before you kind of go through this video is that just have some paper with you. I usually give about just give you guys some time to actually read the question. What I recommend is pause at the just before I start working on the answers, pause the video, try the questions by yourself, and then play the answer just to see how far you've actually gotten through, and you'd be surprised at what you are actually capable of. Okay, so in saying that, let's get this thing kicked off. So what we have here is we've got our first question. It's a nice question to start off with. I mean, this is something that they've done over the last few years, a couple of years actually, where they've had a nice substitution question as a first question. So it's exactly what we're doing. We're going to replace x with -2. So wherever x is, we're going to replace that x with -2. So we're going to rewrite this as 2 multiplied by -2 to the power of 4 minus 3 times -2 plus 5. Now, remember that you are not actually allowed to any kind of calculator in this particular exam. So these are things that you're just supposed to know. And if you can't remember what 2 to the power of 4 is, or -2 to the power of 4, just expand it out on the side here. So basically you're taking -2 and you're multiplying it by itself for about 4 times. All right, so what you have is it's going to be a positive number, and then 2 times 2 times 2 is 16. So we're going to rewrite this as 2 times 16. We've got -3 times -2, which will be plus 6. And we also have plus 5. Now 2 times 16 is 32. So then we have 32 plus 6 plus 5, which gives us an answer of 43. The grade, you will get an achieved grade for this answer, and you have to get the correct answer. Any other answers, numerical errors are not allowed. So if you make a mistake with the calculation, that's just tough luck. So you've got to make sure you get the answer correctly in one go. Okay, so that's question 1A. Let's have a look at question 1B. All right, so what we have is we've got solved this equation. We've got a quadratic that equals to 0. And I know that like last year I had somebody ask me a question about, if I know how to use the quadratic formula, can I actually use it here? The funniest thing is like, I know we kind of discussed this quite a bit in a long time, like, why not? But having a look at the schedule actually says that you need correct factorizing gains in R grade as one of the things. Both solutions consistent with their factorizing. So it actually talks about a lot about factorizing. So I am skeptical on it, so please don't quote me on that. But anyway, how do we go about solving this? So the first step we kind of have to do is we've got the 10 times -9. So we're going to rewrite this as -90. And we're looking for two numbers that multiply to -90 and add up to -27. Now guys, there are a few videos on my channel on how to do this. So I've got some extensive videos on it, like there's about 3 or 4 videos on it. So have a check them out, or just ask me in the comment section, just remind me, and I will put up a link later on, but most likely I'll forget. So if somebody could ask me, that'd be great. But anyway, how we're going to do this is that we basically got this -90 from 10 times -9, and we have the -27 from here. So we're looking for two numbers that multiply to -90, and also those two numbers have to add up to -27. So in this case, I'm going to be looking at -30 and +3, and then -30 plus +3 is going to equal -27. So I'm going to take this quadratic, which is 10x squared, and instead of writing it as -27x, I'm going to rewrite it as -30x plus 3x minus 9. So all I've done is, if you think about it, this part right here is still, the pink part is still equal to -27x. I've just split it up into that kind of weird looking ratio there, because what this allows me to do is I can actually factorize by parts. So I'm looking at the left hand side, factorize it. I'm looking at the right hand side, and I can factorize it. So the left hand side, I've got 10x as a common factor, which means I'm going to get x minus 3. And then on the right hand side, I've got 3 as a common factor, and I'm also getting x minus 3. And it's really important to notice that you get these two brackets, they have to be the same. If they're not the same, then you're doing something wrong, or sometimes you're missing like an extra factor that you need to take out. So in this case, we can see that x minus 3 is a common factor, and I can take it out, x minus 3. And then what I'm left over with is 10x plus 3. So just to refer that the 10x comes from there to here, and the plus 3 comes from there to here. Now, we know that this quadratic is actually equal to 0. And from this point onwards, we've actually got x minus 3 is equal to 0, or our second answer is 10x plus 3 equals to 0. Now, in the first case, we take the negative 3 across to the right-hand side, and it becomes a positive 3. And in this case, I'm going to take that positive 3 to the right-hand side, which makes it negative 3. And I've got to get rid of that 10, so I'm going to divide both sides by 10, which is going to be negative 3 over 10. So my two answers for x is equal to 3 and negative 3 over 10. Or you can actually put down it as r or as well. So basically we're looking, I'm just looking at the grades, guys, and just be patient with me on this one, because the MCAT answer schedule is a bit all over the place in terms of like, there's a lot of things that you can actually get marks for. So let's see. So for achieved, sets up one pair of the factorized brackets shown regardless of signs. Wow, that's interesting. Okay. Yeah, there's I would recommend you guys to actually have a look at the answer schedule for this, because just even though you might be getting the wrong brackets, you could potentially be getting an achieved for it. So what I mean by that is that if you had written somewhere something, I mean, in the schedule they've given like about 1, 2, 3, 4, 5, 6 different combinations. Yeah, so it's quite fascinating what you can actually get an achieved for. Even a completely wrong answer, you could get an achieved for it here. Right, this okay, so this part here might gets you an achieved right here. Both solutions consistent with their factorizing. So let's say you do the wrong factors, but your two answers are correct, then you get an achieved. So for a merit grade, correct factorizing gains regardless of the solution stated afterwards. Oh wow, okay. So for the merit grade, it's up to here. Yeah, as I said, I would have actually given that merit grade is when you actually get the final two answers, but seems like they've actually changed the schedule a little bit around. But anyway, as you can see, even though you might actually go about the wrong way in this question, there's plenty of opportunities for you to gain an achieved grade. Yeah, so we'll move on from that question. We are going to question C. Now, I've spent quite a few tutorials in 2019 doing these types of questions. Now, there is a section called MCAT Live Tutorials. If you guys have a look at that playlist, there should be plenty of videos where I do a lot of these types of questions. So based on that, we're going to kind of get started on this. So what we have got to do is we've actually got to recognize that we've got a base 6 here. We've got another base 6 here, and we have a 36 there. Now, the first thing to recognize is that 6 squared can be written as 36. So I'm going to rewrite this whole equation, but instead of 36, I'm going to put down 6 squared multiplied by 6 to the power of 2x plus 6 equals to 6x squared. All right. Now, the next thing to notice is that our two bases here, they are the same, which means we can actually add up the power. Because think about it, if you have a to the power of m times a to the power of n, then what you would do is you would actually add the two powers if the bases are the same. And right now we've got 6 as the base, so we're going to add those two powers up, and we're going to rewrite this as 6 to the power of 2 plus 2x plus 6 equals 6 to the power of x squared. Now simplifying that, we're going to get 6 to the power of 2x plus 8 equals 6 to the power of x squared. Now once we get to this point, because our bases are the same, so if you look at it, our base is 6 here and our base is also 6 here, that means whatever this power is must equal this power, because think about it, 6 to the power of blue should equal 6 to the power of blue, and whatever's inside the blue things should be equal each other. I hope that makes sense. So what I'm really going to do is just get rid of the 6 completely, not worry about it anymore, and just rewrite this as just the powers. 2x plus 8 equals x squared, because those two powers have to be the same if the bases are the same. Once I get that, I can rearrange this now as a quadratic, because I'm going to write this as x squared. When I bring the 2x to the right hand side, it's minus 2x. When I bring 8 to the right hand side, it becomes minus 8. And what I've got here is a really nice quadratic, because I know that this could be written as product, like we've got two brackets. We're looking for two numbers that multiply to -8 and add up to -2. So that's going to be -4 and +2. And so from here, we can actually say then x minus 4 equals to 0, or x plus 2 is equal to 0. Now in our first case, we've got x is equal to 4, and in our second case, we've got x is equal to -2. So we write down our answer as x equals to 4 or x equals to -2. All right, let's have a look at grades wise, because for Achieved, there's quite a few things that you could potentially have done for Achieved. This part right here, just writing 36 as 6 squared right there, gets you an Achieved grade. Simplifies indices on the left hand side. Sorry, I'm just having a simplify indices on the left hand side. Okay, so if you stuff that up but still you do some kind of simplification right, that could end up getting an Achieved. Consistently generates quadratic equation from the powers. Again, let's say you make a mistake but you end up with a quadratic equation, you could get an Achieved. And even if it's the wrong quadratic equation and you get the wrong question solutions here, you could get an Achieved. Consistently calculates correct values of x from the quadratic. Okay, so that's like, yeah, apologize about this, because it's just a lot to actually take in terms of like what you could get Achieved for. For merit, if you, I don't think this would be an Achieved. I think for merit is if you get the wrong answers from the wrong, like how do I put it? You get the correct answers from the wrong quadratic equation. Yeah, that's what I wanted to say. Correct answers from the wrong quadratic equation gets you a merit. But if you do everything correctly, which is you get to this final answer, then you're looking at an excellence grade. Yeah, apologies about all the confusion, guys, but yeah, this is welcome to MCAT. What can I say? Lots and lots of opportunities to get grades from like multiple sources, even if you do wrong things. All right, so let's go to question D1. Just gonna adjust this a bit. All right, so question D here. Yeah, I think I forgot that whole thing about you know, I hope you guys have read the question so I can actually get on with it. But yeah, hope you guys have had a chance to pause this at some point, have a go through the question, but let's go through it now. What we have got here is we've got a rectangular garden as shown, blah blah blah. If the perimeter of the lawn is 290 meters, then find the value of x. Okay, so again, I'm going to show you guys a couple of ways of looking at this. All right. And guys, I'm going to ask you guys to actually be patient with this particular question, all right? Because there is a really simple way of how to do this question. But I do want to show you guys how normally people would actually look at it. Now, first off, looking at this, we're looking at the perimeter of the lawn, which is not including the garage or the flowers, right? So that means you're looking at this, like basically this part right here. So whatever is shaded in yellow, like colored in yellow, that is equal to 290 meters, and you got to find what x is. Now, the problem though is, like, this distance is given to us, this is given to us, we've got to figure out this one, we've got to figure out this one, this is given, we got to figure out this side, and we've got to figure out this side. So as you can see, there's actually 4 sides that you've got to try and figure out. Now I'm going to show you one of them how to do it, and then you've actually got to do it 4 times, and it just becomes a bit of a pain. All right, let me show you what I mean by. So to find this first, this question mark here, I've got to take the whole distance, which is from there to there, which is 8x plus 3, and then I've got to subtract this little blue bar. So I've got to subtract minus 3x minus 2, and I end up with something like 5x plus 3 plus 2, so 5x plus 5. So I've got to do that for like every one of those question marks. And you know, it's super easy to make mistakes with your subtractions and things like that. So this is what you need to do, and this will work with rectangles, and well, this works with perimeter really. So imagine this, and I want to show you guys this. This part right here is part of the lawn right now, but what I'm going to do is I'm going to move that 2x plus 1 to the edge here. Now the 3x minus 2, which is part of the lawn but it's inside, but I'm going to move it to the outside of my of this big rectangle, so it covers that distance. And same with the x at the bottom here, because if this is x, then I also know that this is x. And finally, if this is 2x minus 5, then I know that 2x minus 5 is here. And if you remember, guys, like, and I know I chose yellow as original color, but let me actually choose this so it makes sense to you guys. So if you remember, this was my original coloring, right? Like, so that piece is going to stay as it is. But remember how there was a piece here. But what I've done is I've moved that piece now to the top. All right, that's what I did with that whole blue, the blue coloring at the top and bottom. And likewise, notice how there was a piece here, but instead of leaving it in the middle, I've actually moved it to the outside, because as you can see, those 2 orange lines, they match up. Then I've got this piece which stays as is, nothing really happens to it. And then I've got all this piece up to here, but guess what? Remember how I had this little X right here? Well, now that's actually gone to the outside because those 2 green things are the same. And likewise, when I have this 2x minus 5 here, I've now moved it to the bottom. And finally, this piece still stays as it is. So what I've created is one big yellow rectangle where the top part is 8x plus 3 and the side part is 6x plus 2. And if we say the perimeter of the yellow part is 290 meters, then we can actually say 2 times 8x plus 3 plus 2 times 6x plus 2 is actually equal to 290. Because remember, if the top part is 8x plus 3, the bottom part is also going to be 8x plus 3. And if the side is 6x plus 2, the other one is also going to be 6x plus 2. I'm hoping you guys got that, how I did that little trick. And it's just a lot more easier to show with, I guess, in front in live. But this is what we have to work with right now. So once we get that, we expand the bracket. So we've got 16x plus 6 plus 12x plus 4 equals 290. So what we've got here is 28x plus 10 equals 290, and then 28x equals 290. Take away 10. We've got 28x is equal to 280. X is equal to 280 divided by 28. And so we can kind of say that x is equal to 10. So guys, grade-wise, obviously getting the final answer gets you a merit grade. Ignore the omission of 290. So if you actually come up with just this part here, you could get an achieved and not actually solve it. Or if you come up with an equation, but you come up with the wrong answer, but your working out is right, you could get an achieved for that as well. So, yeah, so that's basically the idea behind question D, part 1. All right, so part 2 of this question. What we have is, we have got, now, I think this is the thing, right? Whenever they have these kind of garden questions, they always give like a perimeter, and then the follow-up one, it ends up being an area one, because it always ends up being a nice little quadratic equation. So what do we need to do here? At the moment, they're saying that L is x squared plus x plus 1. Okay. That's really strange that they actually say that, but that's okay. Let's try and figure out what it is. And then they're saying find an expression for the area of the lawn in terms of L. Okay, so you know what we're going to do? We're going to try and work out what the area of lawn is first, because once we do that, then we can worry about the L part. So with the area of the lawn, here's the thing. Again, if you had done the rectangle that I had actually taught you before, then you know this. Actually, we don't even need to worry about that one. I just realized we can just look at it and straight away and just do it from here. Because what we have is, to find the area of the lawn, we've got the area of the big rectangle minus the garage minus the flowers. So if we say that area of lawn equals, I'm actually going to write it down here, big rectangle minus garage, the area of garage, minus the area for flowers. So if we look at the big rectangle, that is 8x plus 3 times 6x plus 2, base times height, minus, now we're looking at the garage. So hang on, let me just put that base times height there. That was for the first one. Next, we have the minus the garage. So for the garage, our base is going to be 3x minus 2, and our height is going to be 2x plus 1. So base is 3x minus 2, and height is 2x plus 1. Then for our flowers, we've got a height of x and a base of 2x minus 5. So we're going to subtract that as well. So what we've got here is just a very lengthy quadratic equation. So we have to expand the quadratic out and simplify it, and hopefully we can try and figure out a way to connect that L there. So expanding this quadratic here, we've got 8x times 6x, which is 48x squared. And then we've got 8x times 2, which is 16x. 3 times 6x, which is 18x. And 3 times 2, which is 6. Now what I'm going to do here though, with the second quadratic, I'm going to put a little bracket around here. And I'm going to work inside that bracket first, and then I need to think about bringing that negative out, all right? So first thing is 3x times 2x, which is 6x squared. Then I've got 3x times 1, which is 3x. Negative 2 times positive 2x is negative 4x. Negative 2 times 1 is negative 2. Close that bracket, and I've got one more minus, and I've got this now to consider. So I've got 2x times x, which is 2x squared, negative 5 times x, which is minus 5x. So far, so good. Simplifying my first kind of the x's, I've got 16 plus 18x, which equals to 34x, plus 6, minus. I'm still going to keep things in this bracket here because I want to simplify it first. So I've got 3x minus 4x, which is equal to minus x, minus 2. And of course, in this one, I can actually take out the negative. So negative times 2x squared is negative 2x squared, and negative times negative 5x is plus 5x. Now I need to remove that last bracket, but what I am going to do though, I'm going to simplify things along the way anyway, because I've got 48x squared minus 2x squared is 46x squared. Then I have 34x and 5x, which equals to 39x. The 6 stays as it is. Then I've got negative times 6x squared, which is negative 6x squared. Negative times negative x is plus x. Negative times negative 2 is plus 2. So simplifying this further, I get 40x squared, because I've got my x squareds there and there, which is 40. Then I've got 39x and x, which makes 40x plus 8. So we got up to here, but the problem is that we need to put the area in terms of L. And they say that L is equal to x squared plus x plus 1. All right. Now here's the issue. If we have, and I'm going to write this side by side, right, just to show you guys what it could actually look like. So if L is equal to x squared plus x plus 1. Now we've got the area here as 40x squared plus 40x plus 8. We need to figure out how we can actually bring this L inside of A. So what I'm going to do is I'm going to look at the coefficient of x squared. What I mean by that is that right here. See how this is 40x squared? So what I'm going to do is I'm going to take 40 and I'm going to multiply it with L. So I'm going to do 40L equals, then I'm going to get 40 times x squared plus x plus 1. All right, because notice how L equals x squared plus x plus 1. So 40L, then I'm going to do 40x squared, blah, blah, blah. That means 40L equals to 40x squared plus 40x plus 40. All right. Now here's the thing. I can see that the 40x squared and 40x squared matches up. 40x matches up. But the 40 doesn't match up with the 8 there. So I need to figure out how I can get rid of that 8 and put another 40 in there. And this is where you need to think about this. You can rewrite area here as 40x squared plus 40x, but I want 40 in there, but I don't want the 8. So what do? I can rewrite this as plus 40 minus 32, because 40 minus 32 equals to 8. But now that actually solves my problem here, because this entire thing now, see how this 40x squared plus 40x plus 40, it actually matches here to 40L, which means I can rewrite now area as 40L minus 32, and you're done with this question. Yeah, it is a quite how do I say, long question. Doable, but you just got to be very careful with the working out. That's all. So grades wise, you're looking at a final grade. 40L minus 32 is a excellence. A simplified quadratic gets you a merit, so somewhere here. Consistently rewriting the quadratic, like trying to write it in terms of L, but it's incorrect, could get you a merit as well. For achieved, establishing the expression for the area, so I guess that would be right here at this line for achieved. Expansion of a bracket could get you 2 brackets in the area expression, could also get you an achieved. Using x equals to 10 to state the area. That's interesting. Okay, so you can actually use 10 from the first question and show what the area is, which is a bit strange to do that, but yeah, that's just what it is. MCAT, welcome to MCAT. Cool guys, that is all of question 1. Wow, 30 minutes. Okay, I need to try and wrap this up. Usually these videos take about 50 minutes, but the questions are just getting longer and longer to do, and I'm starting to talk a lot more as well. But anyway, let's go to question 2. All right, so question 2 here, what we have is your classic rearrange question. We've got W equals PQ squared plus R, and they want an equation for P. So what we're going to do is we're going to rearrange so that P is by itself. So my first step is taking R to the left-hand side, which means it becomes minus R. And now this is equal to PQ squared. And of course, then I need to get rid of the Q squared, which means I'm going to get W minus R. And the whole thing is divided by Q squared. Nice and straightforward question for a beautiful achieved. Okay, now let's go to question part, this is part 2 of rearranging. So with this rearranging question, what we have is give the equation for K, C in terms of blah, blah, blah. So, okay, so you got to rearrange for K. So what we have here is we've got FK squared minus 9C squared equals 4D squared plus 16GK squared. Now it's really super useful if you actually have a highlighter in your exam when you're doing this, because sometimes it's just easy to mess things up. So right now I'm looking for equation for K by itself. So I'm going to highlight all the K's. Okay, so I've got a K on the left hand side, I've got K on the right hand side. So that means I got to bring them together. So my first step is I've got FK squared stays where it is, but the 16GK squared comes across to the left hand side, becomes minus 16GK squared. And I'm going to take the 9C squared to the right hand side, and negative 9 becomes a positive, so it'll become positive 9C squared. Cool, that's where we're here at the moment. The next step is we've got K squared on both of those variables, so we can actually take K squared out as a common factor. So what we're going to do is we're going to rewrite it as K squared brackets F minus 16G, and this is now equal to 4D squared plus 9C squared. Now I can get rid of the bracket F minus 16G because I can rewrite this as K squared equals 4D squared plus 9C squared, and the whole thing is divided by F minus 16G. And of course, remember guys, they want for K by itself. Right now we have K squared, so we're going to rewrite this as, I don't know how that happened. We're going to write this as K is equal to 4D squared plus 9C squared divided by F minus 16G, and we're going to put a square root symbol. All right. Now, I always get the habit of this, and I would always recommend you, anytime you're dealing with a square root symbol and you're taking a square root of something, just always put that plus or minus in there. Okay, so grades wise, final grade is excellence, and it does say in the answer schedule that you don't need a plus or minus, so that's all right. For merit, factorizing of K squared terms, so that could get you a merit there. Consistent expression for K, so you make a mistake but you kind of get the right answer, get a merit. One valid step leading to both terms. Wow, really? That's interesting. Okay, that part I'm not sure about, but it looks like one valid step leading to both terms involving K squared being on one side of the equal sign. I would probably then say that this part right here could also end up with a potential merit. Oh, right. Actually, no. Sorry, I read that wrong. That's an achieved right there. But a merit is you've got to do this step, one of the steps of K squared being on both sides, and also factorizing it. That's how you get that merit. So to get this merit right there, you've got to also do this part. Well, you would have done that part anyway, so... Anyway, yeah, that is how you do that question. And let's go on to the next one. So what we have got here is a classic simplifying question. And I kid you not, guys, the number of times I've seen people do this, they see these x squared, they cancel it out, they see the 9, and they go, ooh, cancel that out, and they end up with an answer of something like 3 plus x. If you're one of those people, please watch this video, because you are going to learn how to do this, and trust me, it is a very nice little thing to do here, and easy marks, that's all I can say. All right, so basically what you're doing is you're going to be factorizing both the numerator and denominator. And every time you see this particular thing here, all right, difference of 2 squares, that means you're going to have in the denominator, instead of x squared minus 9, you're going to have 2 brackets. In your first bracket, you're going to have x minus 3, and in your second bracket, you're going to have x plus 3. Because that's what happens when you factorize x squared minus 9. And now in the numerator, you got 3x squared plus 9x. The only thing I can think about is take out the 3x as a common factor. So you take out 3x as a common factor, which means you're going to end up with x plus 3. All right. And at this point, you can kind of see, okay, we've got x plus 3 in the numerator, x plus 3 in the denominator, which means your final answer ends up being 3x divided by x minus 3. I would actually have to say this is probably one of the most easiest merit questions that you could do. Merit is for simplification of expression. You get an achieved if you factorize this or this correctly. Lovely, lovely merit question, which I strongly recommend you guys to just practice more, as many as you can. All right, let's go to question C. Another one of these beautiful, simple. I love these type of questions. You know why? Because there's not much words to read, and you look at this question and you go, yep, I know what I'm doing here. I can just get on with it. So this question here, all they're asking you to do is write as a single fraction. So, and once again, guys, tons and tons of videos available on those tutorials that I've done from last year. Check them out in those playlists. But let's have a look. So what we've got here is we've got to actually make the denominator the same. And I know a lot of people get they look at a fraction and they go, yeah, I'm going to do the upside down barbecue or cross multiply. You know, yeah, it'll work. Don't get me wrong. It absolutely works. But problem is that when you get into later on into deeper into algebra, that cross multiplication can actually become a whole lot of nightmare. So what I always say is look at the lowest common denominator. So between 4 and 3, you know that 12 is the lowest common denominator. That means I want to multiply the the right-hand side fraction with 4 in the denominator, and also the numerator by 4. And as for the left-hand side fraction, I want to multiply the denominator by 3 and the numerator by 3. And when I do this, I can actually say that this is 3 times 8x minus 1 plus, what do we got? 4. 4 times 3x minus 5, and the whole thing is now divided by 12. And you're probably wondering, hang on, if I do the cross multiplication, I'm still getting the same answer. Yes, you're right. In this case, it works out nicely. But if they put an 8 instead of a 3, trust me, you're going to create a lot more work for you than, and especially when they start putting x's and 2x, that's a whole new ball game. But anyway, let's get on with this part here. So we've got 3 times 8x, which equals to 24x. 3 times negative 1 is negative 3, plus 4 times 3x, which is 12x, and then 4 times negative 5, which is negative 20. And the whole thing is divided by 12. Looking at our like terms, so we've got 24x and 12x, which equals to 36x, minus, we've got minus 3 and minus 20, which is minus 23, and that whole thing is divided by 12. So grades-wise, we are looking at a merit for the final answer. Correct expression with denominator. For achieved, correct arrangement for numerator doesn't need to be simplified. So that means you're looking at an achieved some point here. Consistent simplification of numerator. So if you make a mistake with the numerator, but you kind of simplify it correctly, then you can get an achieved as well. When I say correctly, like from the incorrect expanding or something like that. Let's say you make a mistake with it expanding, but then you do all the working out correct, you could still get an achieved for it as well. All right, let's go to question D. Okie dokie. All right, now this question here, you know, when I first looked at it, I was like, oh, this is going to be an ugly looking question. But then, you know, actually going through the question, I was like, it's not too bad actually, because all you have is like, you've got a rectangle, you've got a triangle, and you're trying to find the value of y so that the area is the same. So basically what we have is, we're going to do it like this. Let me see how much space have I got. I've made some good space. That's fine. So let me show you guys. Basically, we have area of rectangle equals area of triangle. Now the area of rectangle, base times height. Area of triangle, half times base times height. Let's start coloring in some things. So base of that rectangle is 3y minus 1. height of the rectangle is 2y. Base of the triangle is going to be 2y minus 2. Height of the triangle is going to be 5y plus 9. So we're going to replace all of those beautiful highlighted colors things with actual variables. So base is 3y minus 1 multiplied by height, which is 2y, equals a half times base, which is 2y minus 2, times height, which is 5y plus 9. So what we've got here is a quadratic equation equals to another quadratic equation. So when you get to this stage, what you got to do is you got to expand the bejesus out of it, rearrange, and you're going to end up with some sort of nice quadratic, hopefully. But let's have a look through this, all right? So the first part I'm going to do is the left-hand side. That looks nice. I'm going to do 3y times 2y, which is 6y squared. Negative 1 times 2y, which is negative 2y. Now I've got this half here, and it's like, you know, I hate dealing with fractions, especially with quadratics. But thankfully, I've actually got this to look at. And I think this is where you start to need to look, no, let me try that again. This is where you need to look at little patterns or little numbers that you can kind of get rid of. Now, if I do half and I multiply that half with this bracket, half times 2y, half times negative 2, what happens is half times 2y just becomes y, and half times negative 2 just becomes negative 1. And just like that, I've gotten rid of that half. And I've still got that 5y plus 9. I don't really multiply that with the half because, you know, it's like I've just multiplied that half with that first bracket, and that's more than enough. Now I've got a quadratic on the right hand side. So 6y squared minus 2y equals 5y times y, which is 5y squared, y times 9, which is 9y, negative 1 times 5y is negative 5y, negative 1 times 9 is negative 9. Okay, next thing is rearranging everything so that one of the sides is equal to 0. So I'm going to simplify the right hand side first because then I can kind of just make things a little bit more nicer, I guess. So what we've got here is plus 4y minus 9. And I'm going to bring everything from the right hand side to the left hand side. But what I'm going to do is I'm going to leave a little bit of breaks just so that it makes it easy for me to actually I'll show you what I mean by. So when I take the 5y squared to the left hand side, it becomes minus 5y squared. When I take the 4y to the left hand side, it becomes minus 4y. And the 9, well, that becomes plus 9. And now this whole entire thing is now equal to 0. So I got 6y squared minus 5y squared is y squared. Minus 2y minus 4y is minus 6y. Plus 9 equals to 0. So at this point, I can see that they factorize quite nicely, actually, because this is just y minus 3 times y minus 3 equals to 0. So therefore, I can then say y minus 3 is equal to 0. Y is equal to 3. So if I go back to my question, what is my question actually asking? Find the value of y so the area of the right angle triangle has the same value, blah, 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 blah. Okay, so there we go. So area, when y equals to 3, the two areas are going to be the same. So grades wise, obviously it will be an excellence question. This much working, yeah, you're looking at an excellence for that y is equal to 3. Now let's say you make a mistake somewhere along your quadratic, but you get a couple of answers, then you know you could get a merit for it. So this is where you're talking about consistent solutions from your quadratic equation. So mistakes, you make a minor mistake, but then all of your working out is fine, you could still get a merit grade. Now for the achieved grade, form equations for both areas. Achieved is there. You can get achieved for area of triangle in expanded and simplified form. Yeah, lots. There's about five bullet points that you can potentially get for achieved. So quite a few little things that you can do. Again, check out the answer schedule just to keep an eye on all those various places that you could potentially get achieved in. Okay, time-wise, 14 minutes to do the second question. That's not too bad considering it took 25 for the first one. All right, guys, we are moving on to question 3. Okay, so question 3. Oh, God, I love these types of questions. All right, guys, so for this question, the challenge is actually trying to go, how do you write this equation, right? So just follow the words itself. Like it actually says, when 20 is divided by my secret number. So we can actually say 20, and then Mary's secret number, we can actually put it as M, for example. It's divided by my secret number, and then 7 is added to this answer. So we're going to divide it by M first, and then we're going to add 7. This gives a solution of 2. Cool. That's pretty much what it is. We've set up this equation, linear equation. Now we need to try and solve it. So the first step is to get rid of the 7 to the other side. And when we do that, we're going to get positive 7. So when it goes to the right-hand side, it's minus 7. Then what we have is 20 divided by M equals negative 5. Now at this point, when you have a fraction equals another number, you could just go cross multiply and just kind of rearrange it real quickly. But, since we are doing this the long-fashioned way, I'm going to show you guys. So bringing the M to the numerator, because I'm multiplying M, because on the other side it was being divided. And from here, I can basically say that I'm just going to rewrite this as 20 equals negative 5M, and then M is equal to 20 divided by negative 5. Because negative 5 is getting multiplied by M on the right-hand side. So then I can say that M is equal to negative 4. Cool. So basically this question is worth an achieved grade, and there is nothing, no kind of extras. You've got to get the right answer there, guys. Okay, so let's go to question B. Okay, so question B, what we have is we've got an inequality. And looking at it straight away, well, the first thing what we need to do is we need to actually expand the brackets. So that's what I'm going to do. 6 times 5 is 30. 6 times negative 2x is negative 12x. Minus 4 times 5 is negative 20. And minus 4 times negative 3x is plus 12x. And this is greater than 5 times x is 5x. 5 times 4 is 20. So on the left-hand side, what I've got is negative 12x and 12x. So that just becomes 0. 30 minus 10, 20 is 10. So I've got 10 is greater than 5x plus 20. Now it's really interesting that they've actually put the x on the right-hand side. Normally what would happen is that, you'd have that x on the left-hand side. But anyway, let's just keep carrying on. So we're going to get rid of the 20 first. When we get rid of the 20 to the other side, it becomes minus 20. So we've got 10 minus 20 is greater than 5x. So in other words, we've got negative 10 is greater than 5x. And getting rid of the 5 to the other side, we're going to get negative 10 divided by 5. And so what happens is our final answer ends up being negative 2 is greater than x. So that is one answer. Now, some of you might have done this from, just to kind of give you, sometimes people can actually end up doing this. They would like to bring all the x's to the, the left-hand side. So you could actually have something like this. When you bring 5x to that left-hand side, it becomes minus 5x plus 10 greater than 20. I'm just going to put that in red so you can kind of see what's happened there. And now rearranging it, so you get minus 5x is greater than 20, take away 10. Negative 5x is greater than 10. And then x is 10. And because we're dividing by a negative 5, you need to remember to switch the symbol. So because we're dividing by a negative number, the symbol actually switches over. And so our final answer is x is less than negative 2, which is still the same answer as what we've got here. And by looking at the answer schedule, both answers are accepted. Yep, both answers are accepted, and you get a final grade of merit for this question. Achieved is if you forget about the greater than symbol and just put equals all the way. then you might get an achieved for it. Expansion of all brackets, getting an achieved. So that's like this, this, and this. And it says expansion of all brackets. So you got to get all three of those brackets correctly. So yeah, again, one of those questions where you can get like multiple options in terms of achieved. Cool, guys. Let's go to question C here. Okay, so with this question here, and I guess whenever you have like an algebraic fraction, your first kind of thinking is, could I actually find some common factors to get rid of? Now, unfortunately, in this question, there's nothing really we can do because there is 1x in the numerator, 1x in the denominator. There's no common factors. So in this case, we do not have a choice apart from doing cross multiplication. So that means we're going to go x plus 2 multiplied by x plus 12. And I'm going to take the x plus 4, which is already there on the right hand side, multiply it with x plus 4 from the left hand side, which is in the denominator. So literally all I've done is I've done some cross multiplication, which is that times that, and then the x plus 4's times by each other. All right, so once I do this, what I've got here is a quadratic equals another quadratic. So expand, rearrange, and then solve. So the first bracket I'm going to expand, I've got x times x, which is x squared. X and 12 makes 12x. 2 times x, which is 2x. And then 2 times 12, which is 24. And all of this is equal to x squared plus 4x. Got another 4x. And got 16. So simplifying this, I've got x squared plus 14x plus 24 equals x squared plus 8x plus 16. Now, because I've got x squared on both sides, they just kind of disappear each other. And what we've got here is a nice linear equation, which is 14x plus 24 equals 8x plus 16. Now, I know I went through that x squared real quickly, but just think about it. The reason I canceled them out each other was because if I take this x squared to the left-hand side, it becomes minus x squared, and that's how x squared minus x squared becomes 0. Anyway, now I'm going to bring all the x's to one side and take all the numbers to the other side. I'm going to leave x's on the left-hand side, so 8x coming over to this side becomes minus 8x. And as for the 24, switching it over to the right-hand side becomes minus 24. Simplifying now, I've got 14x minus 8x, which is 6x, and 16 take away 24 is negative 8. And then I can say that x is equal to negative 8 divided by 6. All right, and of course, I mean, you can actually simplify this answer further to be negative 4 over 3. So grades-wise, you are looking at a merit grade for the final answer. And it doesn't say about simplified answer, it just says correct solution. So you could potentially leave your answer here as negative 8 over 6. As for the achieveds, you've got expansion and arrangement of both sides. So we're looking at the expanding of the brackets. And of course, if you make like a silly mistake, but you just carry on everything correctly, you could potentially get an achieved for that as well. All right, that is question C. We now go to question D. Now, this question here, you're probably thinking, man, I'm doing MCAT. Why am I actually seeing graphs? All right. The reality, guys, is that, you know, algebra is graphs, graphs is algebra, whether you believe it or not. But all it is that, I mean, let's just think about what, even if you just peel away those pictures there, you can still trying to figure out how to actually solve this question. Basically, what you have is you've got an equation of the graph here, right? Which is the parabola that's actually given there. Then you've got equation of a straight line. Now, all you're trying to figure out is the x value of where those 2 points happen. Or in other words, what you got to do is you just got to put the yellow equation equal to the blue equation. And the reason you put them both equal to each other is because of the y. Notice how it says y equals this and y equals that. So that means we can actually just say 7 plus x minus 6x squared equals 8x plus 4. Because basically When the y values are the same, we want to try and figure out what the x values are. Those x values are also going to be the same. So think about it like this. If I take this green point right here, the green point, it's going to have some x value and some y value. We don't know what it is, but both of those points come in the straight line and also the parabola. And then if you look at this other point here, the red point here, let's say that's like this. I don't know, whatever that x value and whatever that y value is, they both come back in the straight line and the parabola again. So that's why we put both of these equations equal to each other. And once we put them equal to each other, we just need to rearrange and solve. Now I've got a negative 6x squared here. I hate working with negative values in front of x squared, so I'm going to take it to the other side. In fact, I'm going to take all three of these things to the other side. And when I do, their symbol changes, which means I'm left with negative 7, negative x, plus 6x squared. Now simplifying this quadratic, I've got 6x squared. I've got 8x minus x, which equals, so I've got plus 7x. And then I've got 4 minus 7 is negative 3. So at this point, I have a quadratic where the a value of x squared is, well, the coefficient of x squared is bigger than 1. So I've got to do that long-winded method. So I've got to go 6 times negative 3 first, which gives me negative 18. So I'm looking for two numbers that multiply to negative 18 and add up to positive 7. Now in this case, it's going to be 9 and negative 2. 9 and negative 2. So that's 7x there. I'm going to split it up as 9 and negative 2. So this is going to be rewritten as 6x squared plus 9x minus 2x minus 3 equals to 0. But let's worry about that equal to 0 later on. So once I get this, I need to split them up into parts, 2 parts. And on my left-hand side, let me have a look. What do I have as a common factor? I have 3 as a common factor, 3x. So I can take that out, which means I'm going to end up with 2x plus 3. And as for the right-hand side, I can take out negative 1 as a common factor, which means I'm going to get that same bracket that I did in the first scenario, which was 2x plus 3. And now, because both of these are common factors, I can take that out and I get 2x plus 3 multiplied by 3x minus 1. So just to reiterate, the 3x is from there and the minus 1 is from there. And of course, remember that this is all equal to 0. So what we then have is 2x plus 3 equals to 0, or 3x minus 1 equals to 0. So rearranging this, we're going to get 2x is equal to, well, 3, switching over to the other side becomes negative 3, and then x is equal to negative 3 over 2. And as for the second answer, we've got 3x. Negative 1, when it switches over to the other side, becomes positive, and then x is equal to 1 over 3. So what we actually have is two values for x. So 1 over 3 or negative 3 over 2. And you can kind of see that here, because this part right here is a positive 1/3. This part right here is negative 3 over 2, or negative 1.5. So you can kind of see that the ratio of it. All right, so in terms of grades for this question, we are looking at excellence for the final 2 answers. For merit, consistent solutions to the simplified. So let's say you make a mistake in your quadratic, but you get up to this part correct here, where, you know, they're not the right x values, but you've done everything else correct. You could still get a merit for it. Factorization of the correct quadratic. So doing this gets you a merit. What about achieved? Equation formed by equating, oh wow, really? And simplifying to a quadratic equation. So this part, getting up to here, gets you an achieved. Consistent factorization of the quadratic equation. Okay. So yeah, so you've got another couple of options, one more option in terms of consistent factorization. So if you, let's say you make a mistake with the quadratic equation, but you factorize it correctly, then you could potentially get an achieved for that as well. All right, so let's go to the last question I'm thinking. Let's have a look at this one here. Alright guys, so for the last question, what we have is we've got an equation of a straight line that passes through these 2 points right here, which is -5, -10, 9, 11, right? And it actually has given this particular equation. Now it says use algebraic methods, but in fact you can actually do this question using how do I say it? You can actually use it using linear algebra, or you could actually use it through well, linear algebra is part of graphs. So yeah, you can use it that way. But let's say you've not actually done any linear algebra, so you don't know what a gradient is, you don't know what a y-intercept is. It doesn't matter, because what you've got here is the most classic simultaneous equations that you can actually think of. Because look at this. What we have is we've got x value here, we've got y value. We have another x value and a y value. Yes, I know those two colors. I've used red and pink there, but that is what. Let's actually do a light green. So we've got 2 points, right? Those are the 2 points that I actually have. And what I'm going to do is I'm going to substitute both of those 2 points into our linear equation. So right now our linear equation is this. It is qy equals px plus 5. So I'm going to do the red one first, right? The red one was -5 and -10. So if I was to do the red one first, then I've got q times y, which happens to be -10, equals p times x, which happens to be -5, plus 5. I hope you guys can catch where I got wrong pen. Where was it? Where is it? There we go. So the -5 is what the x value is. The -10 is what the y value is. So all I've done is I've just replaced the x and y to create this new equation. Now I'm going to do the same thing with the green coordinates, which is 9 and 11. So what I end up with is q times 11 equals p times 9 plus 5. So once again, what I've done here is I've got the 9 there, which is my x value, and then the 11 there, which happens to be my y value, and I've substituted both of them in there, which leaves me with 2 equations. My first equation here is -10q equals -5p plus 5, and my second equation is 11q equals 9p plus 5. So those are my 2 equations right now, and I need to actually solve them using simultaneous equations. So with simultaneous equations, there are 3 different ways of doing this, and you've got to actually pick which one is going to be the one, I would say the easiest one to actually work out with is. All right. And in this case, I can kind of see that I've got a -10 and a q, but like before I do that, I'm going to rearrange these equations. So I'm going to write the -5p. Do I need to? No, let's actually leave it like that. Let's just see what happens. What times tables am I good with? 9? Yeah, let's do 9. Okay, so here's my first equation, right? So it's -10q. I'm going to bring the 5p to the left-hand side because it's -5p. When I bring it over to the other side, it becomes plus 5p, and now that is equal to 5. The next equation is 11q. And I've got 9p, so I'm going to bring it over to this side because then it becomes -9p equals to 5. So these are my 2 equations. Now the problem is I can't just eliminate one straight away, so I have to multiply both of these equations. And looking at this, what I'm thinking is I'm actually going to eliminate q. That means I need to figure out how I'm going to convert these 2 numbers to be the same. And that's nice, because all I need to do is multiply this entire equation by 11. And as for the second one, I'm going to multiply it by 10. So watch what happens. When I do, and this is going to take a bit of time, guys, just be patient with me. So we've got -10 times 11, which is -110q. Then I've got 5p times 11, which is 55p. And then 5 times 11, which is 55. And I do the same for the bottom. So I've got 11q times 10, which is 110q. Then I've got -9 times 10, which is -90p, equals 5 times 10, which is 50. Now, at this point, what I can do is I can actually add up both of these equations. Okay, what I mean by that is that I'm literally going to split it up like this. Have a look what happens. So the first thing is negative 110q plus 110q is equal to 0. So I don't really need to worry about it. Now 55 minus 90, it becomes negative 35p. And then 55 plus 50 becomes 105. So there we go. I've got my first linear equation. Because I can actually say negative 35p. Negative 35p equals 105. That means p is equal to 105 divided by negative 35. And guys, you know, this is where you got to go, well, do I really need to use a calculator for this? Because I don't have a calculator here. The numbers, when they have like these kind of big, ugly questions, is that they tend to generally work out to be really nice numbers. Like they won't give you like, you know, an answer where it's like 2.67 or something like that. So if you're in doubt, just in this case, just take 35, you know, just do it a couple of times. Like, okay, if I do it twice, it's 70. If I do it 3 times, it's 105. So then I can rewrite this as p is equal to negative 3. Now, once I've figured out what p is, I need to go back and work out what q is. And to figure out what q is, I can take any one of these equations, substitute p in, and figure it out. So I'm going to take this one right here. Let me just show you guys. So I'm going to write that down. So I've got 11q equals 9p plus 5. So I've got 11q equals 9. P is negative 3 plus 5. So I've got, keep carrying on, 11q equals 9 times negative 3 is negative 27 plus 5. And then 11q equals negative 22. Getting rid of that 11 to the other side, it becomes divided by 11, which means q is equal to negative 2. So my final answer then is p is equal to negative 3 and q is equal to negative 2. So guys, grades wise, your final answer there gets you an excellence. Correctly finds the value of p or q. So if you find one of these values, either this or this, then you get a merit. You can test values to get a merit as well. So you're like, I guess you're guessing and checking, but I'm not sure how that would work, but that is probably one of the things. For achieved, forms both equations. Wow, just substituting that gets you an achieved. And then consistently combining, so that this part here could get you an achieved, getting to here. Again, a few other things that you can potentially do, guys. Alright guys, that's basically it for this long video. This one, it took about 25 minutes, just over 25 minutes to actually do question 3. Yeah, explaining that can be taking a long time. But anyway, as for you guys, just make sure, as always I say this, you know, leave no question empty during an MCAT, because you never know what grade you might be getting for even the wrong answer that you actually write in. Never leave an empty paper. Always attempt every question that you can, because the MCAT, you know, it's a really weird one, because even if you make like mistakes, really big mistakes, somehow you can actually get like a little achieved grade out of it. And as for those excellence questions, I have to say the 2019 paper one was, you know, rather, they put some good questions in there. And I think if you, as long as you keep practicing these questions all the time, then you should be very well on the way to getting a pretty decent grade in this. And as for the MCAT 2020, guys, really, I don't know when it will be, because especially with all the COVID situation here. But whenever the date is, I will probably be starting live tutorials about, I would say about 6 or 7 weeks prior to the date that they advertise. So just keep an eye out on my channel, and I should start those live stream tutorials leading up to the MCAT about 6 or 7 weeks before the actual MCAT itself. Alright guys, that's basically it. As always, don't forget to like this video, share this video, as there are a lot of level 1s out there that are probably doing this MCAT and would like some help like this. Subscribe to keep up with the latest content, and also when those next tutorials are on. And as always, thank you for watching and good luck.